Theory I told you already in yesterday yesterday class, right? What is a parameter? What is a, why we use it, jet testing, right? Confidence level already told you, right? Yes. So when we use large testing, when the number of sam when the number of sample is greater than 30. No, no, no. Confidence interval is different from confidence level. If you are 90% confident, then you can say and my confidence level is 90%. But confidence interval is different. Confidence interval means range of population mean, very important. Okay, this is called range of a population mean. Confidence interval. Interval means what? Range. Interval means from, let's suppose, from point A to from point B. This is called confidence interval. Confidence interval, no, that is the range of, you can say, yes, you can say like this. No, correct. But when standard deviation is given, right? Okay. This is the formula for finding confidence interval. Okay. First, remember if your confidence level is 90%, very important, you can note down this. If if confidence level is 90%, then the value of Z alpha is 1.64. If confidence level is 95%, then the value of Z alpha is 1.96. This is very important. Always remember, if alpha is equal to 5%, you know what is alpha? Level of significance. Then Z alpha will be 1.96. What is Z alpha? This is called critical value. Critical value means what? Let's suppose this is a graph. Okay. Critical value is called limiting value. This is minus 1.96 and this is 1.96. So this range is called critical range. Sorry, acceptance region. Okay. And when you go outside of this region, this is called rejected region. It means what? If your value, if your value lies between minus 1.96 to plus 1.96, it will be accepted, otherwise rejected. So 1.96, is for alpha is equal to 5%. Okay. If alpha is 10%, alpha is 10% means if confidence level is 90%, right? Alpha is 10% is same as confidence level 90%, right? Then your value lies between 1.64. It means minus 1.64 to 1.96. Uh, yes, it is calculated by using normal distribution. You have studied in a normal distribution, normal probability. Okay, so there is one table. I show you this table. So with the help of this table, it is calculated. But you do not remember uh, you are not required to learn the table. You learn the values only. Okay, this is called table. Okay, so from this table, it is calculated just like logarithm table. There is a table of Z table. You can see normal distribution table. Here Z is written. Okay, so no need to read the table. Just only remember the value of Z at 10%, 5%, 2%, and 1%. Okay, and which is more useful? 95%. So for 95%, the critical value means acceptance region, lies between minus 1.64 to plus 1.64. For alpha is equal to 10%. Mostly 95% comes. Okay. Here 1.96 is given. It means that it is between minus 1.96 to plus 1.96. Okay, right? Okay. Now I tell you how to find confidence interval, not level. Confidence level is what? A confident value. Suppose you are 95% confidence, it means your level is 95%. But we are finding confidence interval. So right here, how to find confidence interval. This is mu. Mu lies between x minus 1.96 sigma upon root n. X minus, sorry, plus 1.96 sigma minus root n. Sorry, sigma upon root n. So you know when the value of z is 1.96, then alpha will be 5%. Okay. So use this formula when alpha is equal to what? 5%, right? Or you can say when confidence level is 95%, right? If confidence level is 95%, or you can say when alpha means level of significance is 5%, then we use this formula. If alpha is equal to 10%, and you know for 10% it is 1.64, right? So only 1.96 is replaced by 1.64 because this is the value of z. Okay, x plus 1.64. Okay, this is for 10%. If alpha is, let's suppose, 1%, 99%. So yes, if alpha is yes. So the range of mu will be what? I am writing in bracket. This is the range. Okay. So you can also write in this way. Uh, x minus plus minus means one sign is minus and one sign is plus. It will be I think 2.54 sigma upon root 2.58. Okay. Yes. Note this formula. Now we will do with an example. So the general formula will be what? X plus minus z alpha. Z alpha means if alpha is 5, then alpha will be 1.96. If alpha is 10, then z alpha will be 1.64, right? If alpha is 1%, then it will be 2.58. Yes, 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 z alpha. One more thing, if alpha is 0.01%, you can say when confidence level is 99.9%, always taken z alpha is equal to 3. Okay. Yes, almost all. You can see the table. Almost all means what? Almost all means 99.9%, right? Okay. Then we consider uh, z alpha will be 3. X bar means sample mean. So because with the help of sample you are finding the range of mean. Okay. Then alpha bar, no. X bar. Yes. Okay. Now we see example. Okay. Read this question. So yes, random samples. It means number of sample is 200, right? So I'm writing here n is equal to 200. Made by a certain machine during 1 week showed a mean. So this is the mean. So mean of what? 200 balls. It means this is sample mean. Newton and a standard deviation of 0.042 Newton. Okay. Find 95% confidence limit for the mean weight of all bearing. So here alpha is what? Yes. Here confidence level is also called confidence limit. Confidence level is 95%. It means alpha is 5%. And we have to find what? No, no, no. We have to find confidence limit. Confidence limit with confidence interval. Okay. So how we will find? For finding confidence interval, see, uh, these are given. Always write given, and now to find. Okay. If alpha is equal to 5%, Z alpha will be 1.96. Right. So first we calculate what? Okay. See, x bar minus 1 point. You can write here. Z alpha into, okay, x bar is what? Z alpha is sigma is 0.042 upon root 200. Okay, 0.824 plus 200, right? Now we are calculating 1.96. 0.00582, right? 0.81818. Yes, yes. So you can use calculator for this part. This is calculation part. Okay. So you can see the range of population. Yes, yes, yes. So because this is same part on both sides, so we calculate this first. Okay. So one time is subtracted and one time is added. So when you subtract this, you will get what? 0.8181 and 0.82. So your population range lies between 0.8182. Understood? Yesterday, I give one rough idea. uh, rough idea of when mean and standard deviation is given. You can say from 70 to 78, but actually it is calculated by using this formula. Okay, only mean is subtracted with standard deviation is not sufficient. This by using this formula we can say the range of uh, marks lies between these two days. Okay, so whenever we find the range, it is always necessary given its number of sample. Okay. Yes, this is confidence interval and this is confidence level. Confidence level is 95%. Okay. Confidence interval is also called confidence limit. Understood? Clear? Okay. Noted? So in answer, it is taken round figure 0.819 to 0.83. Okay. You can say 0.82 to 0.83. Right? Can you try second one? No, no, no. Sample is sample is 60 because you read and you will get random sample of what? Of how many sample? 60. And the mean value of to be 45. This is mean value. Yes, you can read again. The mean value of random sample of 60. It means the number of sample is 60 items. This is 60 items was found to be this. So this is standard, mean. And which mean? The mean of sample, that's why this is sample mean. With standard deviation 40. So find the confidence, 95% confidence limit for the population mean. 155, right? So 145 plus 10.2, right? 155.12. Yes. Right? Okay, try this also. Third, the more you practice, the more you will learn. Sample mean is not given, right? Okay. Only standard deviation given. So you can add there sample mean is 0.31 and number of sample is also not given. This question is incomplete, okay? Because without mean and sample, number of sample you cannot determine. But in the answer, in the solution, you can see it is taken sample mean 0.31, number of sample is 75, but it is not given in the question, right? Yes. I think question is incomplete. Okay. Try this first one. So here sample size. Sample size means number of sample. And sample mean is 62.15. Yes. No, no, no. Standard deviation. Standard deviation is what? Sigma. Yes. Alpha will be 1%. So alpha always comes in percentage because this is probability. The chance of doing error, level of significance, right? Okay. If if it is not given, I told you what to take in 95%. If a confidence level is not given, then always take 95%. Here alpha is 1%. Then Z alpha will be 1.5. Okay. Yes, yes. 64.72. Yes, answer is correct. Okay. Okay. So many questions are there. I will send this PDF. Okay. Now I tell you hypothesis testing. You understood what is how to calculate confidence interval. Okay. Confidence. Okay. One more thing I tell you. Confidence interval is also called central limit theorem. Yes. Very important. So this is called. I am writing here. This formula. Yes. This formula is also called central limit theorem. So why? What is central limit theorem? Central limit theorem is for finding the confidence interval. Okay. So I'm writing here. You can note down. Central limit theorem is used for finding the confidence interval. Okay. And the formula for central limit theorem is this, right? Okay. You already done with two questions, right? Central limit theorem is nothing. Whatever you are finding confidence interval, that is central limit theorem. Central means what? You are finding the range. Okay. The range of population means. It means that your population mean lies between this point to this point, but not more than this. Okay. Yes. 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 Okay. Now see. I already told you what is acceptance region, rejected region, right? Error. Yesterday we discussed error. What is error? If H0 is true and H0 is accepted, this is what? Sorry. If H0 means null hypothesis is true, but it is rejected, then this is type 1 error. And if H0 is true, whatever you are guessing and it is true, then your decision is correct. But if your hypothesis is rejected, this becomes type 1 error. Okay. And this is called alpha, also called level of significance, right? Suppose you are guessing anything false, but it is accepted. So this is called type 2 error. Type 2 error is represented by beta. Okay, and see, you are guessing false things, but it is accepted. False thing is accepted, it means type 2 error. And your false thing is rejected, it means your decision is correct. Okay, confusion matrix. Where you study? No, you will get in a choice for testing confusion matrix. So we can discuss it. So confusion matrix. See, this is called when you form in matrix. It becomes confusion matrix. For example, see, actual positive, actual negative, predictive positive, predictive negative, right? Okay. This is true positive. This is false negative. This is false positive. This is true negative. That's why this is called confusion matrix. So, so same thing is decoded in this way. Let's suppose you are guessing anything true. Okay. Suppose you are guessing anything true and it is accepted, then your decision is correct. Suppose you are guessing that today it may be rain. Suppose it may be rain today. You are guessing what? Yeah. Suppose you are guessing that today India can win, right? And it will actually win. Then this is then your decision is correct, right? But you supposed what India can win, but it is not win. Then this is yes. This is called type 1 error. H0 is rejected. H0 is rejected means India not win. And you supposed what? India win. India can win. If India actually wins, then your decision is correct. Now you understood? Okay. H0 is false means what? Suppose you are guessing that India cannot win. You suppose what India cannot win, but your hypothesis is rejected. It means your decision was correct. You suppose what India cannot win, but actually it wins. H0 is rejected, right? But if you suppose India cannot win and it is accepted, India win, it is type 2 error, right? So same thing, this is called confusion matrix because when you read this, you will get confused. But when you see this matrix, you will understand, right? Okay. So this is not important, much important. See, now we see what uh, yes. So yes, hypothesis testing for large sample. We have seen how to find confidence interval. Now we will test hypothesis for large sample. Large sample means greater than 30, right? Hypothesis testing means you are testing that your population means, let's suppose I am saying population mean is 50. Now you will test my hypothesis that it is actually 50 or not. Whatever data are given, so with the help of this data, you will test whether a population mean lies between these value or not. Okay. So here first step will be what? Hypothesis. So there are two types of hypothesis. One is null hypothesis. Null hypothesis is represented by H0. Okay. So let's suppose your population mean is mu zero. This is constant. And second thing is alternate hypothesis. It is represented by HA. Let's suppose mu is not same as mu zero, right? Second step is test static. The second step we will do calculation part by the formula x bar minus mu upon sigma upon root n. This is formula. Okay. Yes. This is calculation part. Third step is alpha. If alpha is not given, take 5%. And if it is taken 1%, 2%, 10%, then we will do accordingly. Okay. If alpha is 5%, then Z alpha will be yes. And fourth step is we will check whether my calculated value lies in this range or not. Okay. Okay. Let's suppose this is 1.7. Let's suppose we calculate and we get 1.7. So we know that from minus 1.96 to 1.96, 1.1.7 lies between these two values. If it lies, then you can say it is accepted, right? Yes. If calculated value Calculated value means the value of this part lies within, this is called critical region. Okay, critical region or acceptance region, any one you can say, within critical region, and this is called critical value. I write here critical value, and this is called critical range. Sorry, critical range or critical region, or you can say acceptance region. Okay, then null hypothesis is accepted. Very important. Okay, if your range, if your value lies between critical region or acceptance region, then you can say my null hypothesis is correct. It means that whatever I am guessing, it is true. Okay, so these are four steps. So with the help of these four steps, we will find hypothesis for large sample test. Okay, you can note on this. Yes, if number of sample more than 30, then we will use this. Or no need to find confidence interval. Okay, so if you find confidence interval, sometime range is not asked. You will ask only find whether it is accepted or rejected. Okay, yes. No, confident that alpha is critical value because yes, because alpha is 5%, so 95% is confidence level. If it is not given, then yes, then consider 5%. Yes. Okay. Okay. We see with some example. See first question. A random sample of 50. Randomly you have taken a sample of 50 items, right? So I'm writing here given n is equal to 50. 50 means what? Greater than 30. So consider large sample test. So a random sample of 50 gives mean. Mean means sample mean. And variance. Variance is what? You know variance is sigma square because sigma square is variance. So sigma will be yes. So when you calculate, you will get 3.2. So indirectly, standard deviation is given 3.2. Okay. Now, when you further reading, can it be regarded as drawn from normal population with mean 5.4? It is saying that if level of significance is 5%, can its population mean be 5.4? Understood? Read the question once again. It is saying that if these data are given, can you say that its population mean is 5.4 or not? Okay. You can also check by using by finding its confidence interval. But here no need to find confidence interval. We will check by hypothesis. Okay. So your first step will be hypothesis. Yes. So null hypothesis. Null hypothesis is H0. Here mu is what? 5.4. Alternate hypothesis is not 5.4. Second step is testing. So x bar minus mu. X bar is 6.2. Mu is 5.4 and the sigma is 3.2 upon root 50. So first we calculate this. Okay. So calculating 6.2 0.8 0.452 1.65, right? C. Uh, Third step is alpha. So Z alpha will be, okay, and you can see this is minus 1.96 and this is plus 1.96. So 1.65 lies between this, right? So you can write since calculated value is, yeah, calculated value lies between acceptance region. Sometimes it is taken as positive. If it is taken positive, then always say my calculated value less than 1.96. Positive value means you are considering from 0 to this part, right? So its value, if its value is less than 1.96, then you can say it is accepted. If it is greater than 1.96, then you can say it is rejected. So null hypothesis is accepted. It means that you can say its population mean can be 5.4. Okay. Yes. 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 If you find its confidence interval, you are getting 5.313 to 7.08, right? And you can see 5.4 lies between these two values. Yes. So without finding confidence interval, you can check by this method. Okay. In this case, no need to find confidence interval. Just only check whether it lies or not. So by using this method. Uh, you tell. So we can finish this jet testing. Yeah. Today we finish the jet testing. Next time we will start P testing. Can you try this? Just only identify what is sample mean, what is standard deviation, how many number of sample correctly. Then only you will get the answer correctly. Sometimes it is very confusing. Yes. 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 No, no, not mu. Yes, yes, mu is 5. Sigma is 2. Okay. Check whether it is accepted or rejected. Okay. Yes. Uh, you are getting minus 5.56, right? So this is minus 1.96. So minus 5.5 lies here. Okay. And if you take positive value only, then you can say this is greater than 1.96. So null hypothesis rejected. Yes, yes. Then you can take 5%. Even if you take 99.9%, then also it is greater than 3, right? Critical alpha. Yes. So yes, I told you. You can also take a positive side only. If you are taking positive side, then always compare with 1.96. If your value is greater than 1.96, it is rejected. Okay. If value is less than 1.96, it is accepted. Okay. If you can you find the confidence interval of this? Take alpha is equal to 5%. In question it is not asked, but you can verify by finding confidence interval. So find its confidence interval. 70. Yeah, you can see 5 do not lie in that range, right? That's why it is rejected. Now you understood, we can verify by using hypothesis or by finding confidence interval, right? But if in the question paper, if confidence interval is not asked, then don't find confidence interval. Okay. Okay. Try this question. So what is X bar? Yes, because this is mean for 100 sample, and this is average. Average is mean for yes. Now calculate. So it is greater than 1.96. No, no, it was taken mistake. Right, 1.96 because alpha is 5%. Uh, yeah, yes, yes, yes. This is, I think, this is for some other figure, other question. I think this is no, no, same question. So write 1.96 there. Okay. So do yes. Do last question. This is a tire company claims. I think you understand the concept of jet test, large sample test, right? Okay. Which is less than 1.96. So it is accepted. Okay. Okay. So there are many questions. I send this PDF. We can solve this. Okay. One more topic is remaining in this part. We can finish this. It will take 5 minutes. No, jet test. Same for jet test. Okay. So whenever two samples are given, okay. So first we find standard deviation, common standard deviation. So right here for two sample test, for two sample and both sample are large sample. Okay. So standard common standard deviation will be S1 square. S1 square means no. First standard deviation, second standard deviation square. This is N2 and this is N1. This is N1 and 2. Okay. Now you can see the confidence interval will be what? X bar minus Z alpha into S plus or minus. Write this formula. Here S is what? This value. Okay. No need to write divided by root n because root n is calculated here. Okay. Yes. 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 For example, you can see this question. There are two samples. First sample size is 400. It means N1 is and N2 is 250. Mean means what? Okay, one more thing. This X bar becomes what? X1 bar minus X2 bar. Okay. Okay. So first we find X bar, common mean. So common mean will be 124 minus 120. It is 4 minus. No. Okay. Sample 2. This is for sample 1, sample 2. Okay. Now we have X bar is 4 and we will find S. You know, finding S. S1 square. S1 square means 14 square upon 400. 12 square upon 250. When you solve this, you are getting 1.032, right? Okay. Now put the value here. If alpha is 5%, then formula will be 4 plus minus 1.96 into 1.032, right? Okay, so mu is equal to 4 plus minus 2.02. So when you subtract with 2, 1.98, 6.02. So this is confidence interval for two sample. Okay. So your uh, confidence interval lies between 1.98 to 6.0. Understood? Yes, yes, yes. Can you try this first question? First or second, do anything. So average marks, what you are doing, first or second? Okay. Five point five. It's coming. Okay. Okay. Do one last question. The average of marks. It's no. See, for x bar only take minus. So it will be, yes, x bar will be 300 minus 250. This is sorry, this is name. No, standard deviation. This is S1, this is S2, and this is x1 bar, this is x2 bar. So x bar will be x1 bar minus x2 bar. 87 minus 84, it is 3. So S will be, put the value of S1, S2 here. Yes. Okay. So I think you will get 1.5. So 3 minus 1.5 to 3 1.5. 3 plus 1.5. Okay. Two last question. Second. So write everything in this format. The average of marks obtained by 15 boys. So NOG is 50 and their average is 65, right? And S1 is 10, right? And the average of marks obtained by 40 girls. You can see all the samples are greater than 30, right? Yeah. Yes. Understood? So, okay. So I send you this PDF. One more, you can see hypothesis testing for two sample. So large sample will be finished. Okay. So already told you what is central limit theorem, hypothesis, type 1 error, type 2 error, right? So next time we will discuss t-testing. Okay. Yeah, I send. Yes. In next class, we will discuss this a detail of two sample large testing hypothesis. Then we will continue t-testing. Okay. Yeah, no problem. Tomorrow I am available. Yeah, no problem. You can even put in evening also.